Thank you for coming along today and welcome to this talk, which will be delivered shortly by Dan Schien. I am Claire Eatock and I'm from the faculty's Industrial Liaison Office, and this talk today is part of our Faculty Research Showcase event, which is a week-long event just to showcase some of our research that's taking place in engineering at Bristol. If you have any questions for Dan today, there will be a Q&A at the end of the presentation, so please submit any questions you have in the Q&A tab, which is at the bottom of your Zoom screen. And without further ado, I will now hand over to Dan, who will talk about understanding and mitigating the environmental impact of digital services. Thanks, Dan.
So thank you very much for everyone's attention to join here in my presentation. My name is Dan Schien. I am a lecturer in computer science at the University of Bristol here in the Department of Computer Science. And the work that I'm presenting here today is all about understanding and mitigation the environmental impact of digital media. This is research that we carry out in our group together with Professor Chris Priest. Over the last decade or a bit more, we have carried out research in exactly that question, and we believe we've got some important messages for you today. Let's start with some context. Very high level, regarding climate change. You may be aware that the Paris Agreement has announced that we want to reduce carbon emissions by 42% by the year 2030 across the economy. And the important question I've got for you today is whether or not you believe that's feasible for the ICT sector. So the ICT sector is the information and communication technology sector. And do you think that is possible to achieve or not? Now that's of course a rhetorical question. I don't expect an answer, but we can talk about that after the presentation if we want. The important point I want to make is that it will be very difficult for anyone to answer that question because the current impact of the ICT sector is very poorly understood. So to put this into a graphic, there's a big question mark behind the question of whether or not streaming, for example, is dirty. But the question applies to video streaming and to many other uses of ICT technology. And consequently, if we don't know what the footprint is today, then it's going to be very, very difficult to judge in 8 years' time whether we did reduce it by 42% or not. Now, there have been estimates of the energy use and the associated carbon emissions from the combustion of fossil fuels. And those studies, they do agree that the energy use is big. It's significant for us to work towards reducing it. And the estimates, they say that it's in the order of the resulting carbon emissions from the use of electricity are in the order of that of the aviation sector. So definitely worth us addressing. But importantly, these numbers, they come with a lot of uncertainty, and our work is about reducing that uncertainty and also taking it from a sector level perspective to the perspective of individual organizations. We have worked to a large amount with industry. For example, in 2011, we worked with The Guardian newspaper. At that time, The Guardian was in a phase of transition from a business model that relied chiefly on printed paper to one that was based on digital technology. If you may know that The Guardian was pioneering or was very dedicated in changing their strategy around that time towards a digital first model. And this and this is important. The experience with the Guardian is important because it represents well one of the chief problems that there is when it comes to assessing the environmental impact of ICT services, and the problem is one of supply chain transparency. Supply chains are product systems where organizations are connected in a network to provide their services, and um, these supply chains, you find them in all sorts of sectors. For example, in the paper industry, where these supply chains and their environmental impacts are studied since several decades, and the methodologies are well established, and the data is there, the transparency is there to understand the environmental impact from, for example, the production of paper. But the same is not true for the ICT sector. There are a variety of reasons. One is that the supply chains in the ICT sector are more complex to some degree. They also change faster. The IT sector is very quickly innovating. But then there are also reasons, maybe you want to say that there is a certain amount of complacency, that the sector didn't take seriously the need to provide more transparency. And one of the ways in which supply chains become relevant for supplying digital services is the use of data center infrastructure. So, for example, in the cloud, hosting in the cloud is very important for the Guardian and most other organizations, and the transport of data from a data center to a user via networks. Those two systems, they wouldn't be operated by a service provider. The Guardian doesn't operate the networks, and they don't operate the cloud data centers. They pay every month in order to get those services, but they don't have access to data regarding the actual energy use and the associated carbon emissions. And in our work, we then analyzed how those systems work. We extrapolated what the resulting energy consumption is, and then carried out an assessment of the portion of the associated carbon footprint that should be attributed to the Guardian. A couple of years passed, and then we started working with the BBC. They were also in a transition. Here it was the move from terrestrial broadcast or satellite and cable TV towards an increasing amount of video on demand consumption by the audience. And again, they wanted to understand what is the implication for energy use. Additionally, radio frequency is a very short resource, a scarce resource, and there's an interest to free up some of the spectrum for terrestrial broadcast and then use it again for the ICT sector, but also for other purposes. And this is another motivation to strategically evaluate how does this move to video on demand away from other channels affect the energy consumption. So this is, I think that's pretty clear how intransparency regarding supply chains makes it difficult for digital service providers to assess energy consumption and carbon emissions. The other problem is very practically sustainability practitioners working in these organizations. They are experts for environmental methodologies, but they aren't necessarily expert when it comes to understanding how these digital services work. And over the years, we have developed the know-how and the experience of talking to those parties, to both the parties, the technical experts in these organizations building the services, and our background as computer scientists helps. And then we also have the understanding of the environmental science, and we can talk to those two parties to then arrive at these assessments. But assessing the environmental footprint is only one dimension of our work. The other is then to think about what can be done in order to change the design such that its impact is lower. Environmental design of digital services is the other dimension. So methodologically, we apply a methodology called life cycle analysis, LCA, and we carry out a process-based assessment where we look at all of the individual activities that are carried out when a service is delivered. I mentioned data centers and networks, and we also include user devices in the home and outside. And we also combine that with an understanding of the actual user behavior. ICT systems are heavily instrumented with monitoring. So user analysis is the key word here. And we can use that to understand how the behavior of the users affects the energy consumption during the consumption of the service. And both of these together, we can then use strategically to evaluate design alternatives. So here's an example. In 2019, we carried out an assessment of the carbon emissions of YouTube for the year 2016. And high-level result was that we estimated the electricity consumption to be in the order of 19.5 terawatt hours globally, and associated carbon emissions of 10 megatons of carbon dioxide equivalent. But importantly here, we went one step further after the assessment, and we asked, what could YouTube do in order to reduce those carbon emissions? And the investigation started with the observation that many users would listen to YouTube as an audio stream only. So they would use YouTube like many others would use Spotify, not watching the screen, not looking at the video, but only listen to the audio. And we then evaluated how could a change of the service such that we reduce the data volume on mobile devices chiefly result in reduced carbon emissions, because we're saving data volume, especially in the mobile network. And this and our estimates, they suggest that it's definitely a design intervention that is worth considering. I want to return to the problem of supply chains and to the context of climate change and setting targets. Many of you will have heard of the Science-Based Targets Initiative, which is a global project that tries to start with the goal in mind of 1.5 degrees maximum warming until 2050, and then works backwards to understand what do we need to do in order to get to this maximum warming. And of course, the work backwards will allow us to then set targets for individual sectors in order to cap carbon emissions on the planet. And the Science-Based Target Initiative has received a lot of support. Many organizations are signing up to this, including digital service companies. The problem is only that, for the same reasons that I described before, those organizations, they aren't in the position to calculate their current emissions, and hence they can't set targets. And we had the opportunity to work together with an organization, an environmental consultancy organization called Carnstone Partners in 2019 to turn the expertise and the methods that we have developed over the last years into an online tool called Dimpact. And this online tool is a self-service tool. Organizations can sign up to use it and then enter data across about their digital service into this web user interface, and out comes a report of their carbon emissions. Now, when one creates such a tool, this wasn't the first tool. Other organizations have tried this before, but failed, sadly. And one of the reasons is that one always has to balance generalizability and specificity. If such a tool is too general, then the outcome is associated with too much uncertainty for the results to be of practical use. And in order to avoid this problem, we have started focusing on specific modules, specific sectors, and associated modules. So the first sectors that we looked at, or the types of digital services, are video streaming, advertisement publishing services, and business intelligence. This is a snapshot of the organizations using Dimpact. As you can see, many of the, well, all of the broadcasters in the UK have joined. The BBC is there, Sky, ITV, Channel 4 has also recently joined Dimpact. Netflix is using it to estimate the carbon emissions, their carbon footprint. Also, Dentsu, which is one of the largest advertisement companies in the world, and many other organizations, some of which you will recognize, BT as well. Big question, how does it work? How does Dimpact work? Here's a snapshot of the conceptual composition of the Dimpact tool. At the very bottom, there's a calculation engine that we constructed. And then on top of these are those modules for individual services. We bring in generic data, for example, regarding power consumption of user devices, and then each organization will enter their specific data in a sandboxed environment. There's a firewall in between the workspaces for each organization, so any data that an organization enters stays private to that organization. And then they just press a button and out comes a report that helps them understand the hotspots in the digital delivery system. Now I've got a couple of those process network diagrams here. This is, of course, much too small font for you to decipher. It is maybe, the purpose is to illustrate some of the detail that goes into these models. These are not the actual Dimpact models. This is a very high-level conceptual overview of the systems that we model. We always model those end-to-end, meaning we include data centers, networks, and user devices. This specific diagram here is from the BBC. There's a white paper associated with it that is publicly available. If you just Google my name, BBC white paper, then it will come to you. Or I'm happy to post a link into the chat afterwards. And this is the process model for the YouTube paper, which I'm also happy to share the reference with afterwards. Yeah, so as I said, many organizations have already signed up, and the exciting bit is that with those media organizations coming in, we will have more transparency for the sector. We're now at a position where almost all video providers in the UK are using Dimpact, so we can confidently say what is the carbon emission associated with streaming and watching television and streaming video in the UK. What's ahead? We want to construct more modules. We want to standardize the tool. This is based on standard methodology, but we wanted to get to the point where there is an auditing possible by independent parties, and all of the results, all of the reports that come out are can be compared like for like. That's on the roadmap. I think that's it for today, and I hand over back to Claire so that we can have a conversation.
Thank you, Dan. So one of the first questions is really about the consumer, and how is all of this work beneficial for the consumer?
Thank you. I would say the consumer in the first instance benefits from this increase of transparency. Coming back to this initial question of how dirty is streaming? Yeah, Netflix have already reported on their carbon footprint using the Dimpact tool, and they, their estimate describes the carbon intensity per hour watching across the entire um, portfolio of different devices that their audience is using. So mobile phones and televisions on the other end, and the average footprint is about 100 gram of CO2e at tops. It will be it's slightly lower than that, but this is it's lower than 100 grams. That's the important headline figure.
Another question, and I'll see if how you can answer this one, is, are cryptocurrencies environmentally justifiable? I'm not sure the relation, but
I think we can, if we don't have anything else to talk about, then we can review this question. But I think I'd like to focus on questions that are specific to my presentation first.
That's what I kind of was looking at, the relevance of that question. And in terms of this research, what would you see as the next steps for this research following this?
Yeah, as I said, so specifically for Dimpact, we have got concrete plans that we want to standardize and have verification and auditing in place. I think that's important, especially when organizations use these outputs for their non-financial reporting. For our work, I think our very concrete ambition is to expand the scope of our analysis to include the manufacturing and the end of life use phase of products. Now, at the moment, we're only representing the use phase, energy consumption, electricity consumption, and associated carbon footprint. But it is very clear that the construction of all of the devices, the manufacturing of the devices, associated resource extraction is significant. But we want to know how significant is it. And again, there will be many questions that will resolve from a better understanding, and we can use that to better design, to green the provision of those services.
I think the next question really comes from sort of an understanding of measurements of use of energy and so on, which is about how does 100 grams of CO2 equate to, say, driving and air conditioning in, for example, a cinema?
Yes. So I don't know about air conditioning in a cinema, but when driving, I think the European Union fleet average carbon emissions for combustion engine vehicles is 160 gram per kilometer. So with a number like this, you can extrapolate that you can drive a bit more than half of a kilometer with the average vehicle. But again, it's important to understand that there is a significant amount of variability depending on what user device you're watching with. If you're using a big television, then the energy consumption will be much higher from using a mobile phone, for example.
And final question, in terms of sort of your own research, how would you like to work further with industry in the future?
So there is no end, no researcher who will ever be satiated with their interest for data. Yeah, but that's a very basic interest that researchers want more data to better understand the world. I think all of the work that we have done in the more than the last decade has been around impact. We have been always, I think this comes from our interest in sustainability topics. We are genuinely driven by using our work to make a difference. And so if an organization uses the outcome of our work to change what they do, even if we just have the feeling that their understanding has grown, then that's an important form of impact, and that is very motivating. Yeah. But I think some very concrete things are around those next frontiers regarding the manufacturing of devices. Another area is governance going forward. We want to understand what role does governance play in order to continue this increasing the transparency.
Absolutely, I think has a major part to play.
Yeah.
I think that's come to the end of the session now. Thank you, Dan, for speaking today, and thank you for everybody for attending and for your questions. If anything you've heard today has captured your interest, please don't hesitate to get in touch with us. We will also follow up after the showcase with contact details if you would like to have a further conversation about anything you've heard throughout the week. Thanks again and have a good afternoon.
Thank you so much, Claire. Thanks.